Hello everybody. As promised, we're going to go over the class practice problems. And as you can see, this first one, they want us to calculate the mass of aluminum. So that right there is what we're looking for. So let's call that B. We want the mass of aluminum. We are given 50 liters of HCl. So our given is A. And we have 50 liters. And what catches my eye here, this one is at STP. So we're looking at a mass to volume problem here and at STP conditions. If you remember the flow chart, okay, when you're going from volume to mass, okay, did I say mass to volume? I meant volume to mass. So when we're going from volume to mass at STP, the first thing we got to do is we got to change the volume into moles, and according to the flow chart, we're going to divide by 22.4 liters. Now, if you look at the problem, I'll go back here so you can see this. We're starting with 50 liters of A, okay, which is HCl. So if you recall, for every 1 mole at STP, it occupies 22.4 liters. So when you do the math and you divide, you end up getting 2.232 moles of HCl. Once you get moles of A, then the next step is to multiply by the mole ratio. B over A in this problem is 6 over 2. Okay, you can also reduce that to 1 over third. Eventually, you're just going to divide by 3, and you're going to end up getting 1.4881, and now that's moles of aluminum, which is our unknown, our B. And then the last step is to go from moles to mass. We need to multiply by the molar mass of aluminum. Now remember what I've told you many times, never use coefficients to find molar mass. If you look at the periodic table, aluminum is simply 26.98 grams per mole. So if we get the moles of aluminum and we multiply it, let me see if I can do that down here. Okay, if we can multiply this by 26.98, all right, the moles will cancel, and we're going to get the grams of aluminum. You're going to round it to 3 significant digits, and you end up getting 40.1 grams. So the answer here is you're going to end up making 40.1 grams of aluminum in this volume to mass problem at STP. Okay, so that was the flow chart that we used to solve this problem. All right, let's move on to the second practice problem. This time we have magnesium nitride, and it's reacting with water. So as we read the question here, they want to know what volume of ammonia. Ammonia is all the way over here. We're looking for this, so let's put B here. Okay, so we want the volume. Volume's going to be in liters. Okay, and notice that they give us a pressure and they give us a temperature. They give us the 2. That means this is not at STP. Now, the given here is that we got 5 grams of magnesium nitride. So magnesium nitride is all the way here on the left, and that's going to be 5 grams. Now, when you're doing one of these, the first step is to go from grams to moles. You always want to convert grams to moles. So why don't we do this? Let's find the molar mass of magnesium nitride. There are 3 magnesiums, and each one from your periodic table is 24.31. When you multiply that by 3, that's 72.93. And there are 2 nitrogens. Each one is 14.01. Multiply that, that's 28.02. And when we add this, the molar mass is 100.95 grams per mole. Okay, I'm going to flip over to the next page so we can complete the problem. So here we're going from mass to volume, but it is not at STP, so we can't use 22.4. Now let's do the first 3 steps because they're going to be identical. All right, we have 5 grams of magnesium nitride. We're going to divide it by the molar mass, which we just found to be 100.95 grams per mole, and we're going to convert it to moles of the given, or A, and that's 0.0 0.04953, and that's moles of the given, Mg, 3, and 2. Once we're in moles, we can go from A to B, from the given to the unknown. The mole ratio, if you saw from the problem, okay, the mole ratio is B over A, which A is over here. So the mole ratio this time is 2 over 1. So let's multiply here by 2 over 1. And you're going to get 0.09906. And that's moles of B. B is ammonia. Here's what we got to do though. We cannot use 22.4. So what we need to do to go from moles to volume is we got to use PV equals nRT. In other words, the ideal gas law. The only thing we're missing is V. So if you rearrange that equation and you put V is equal to nRT over P, we have everything we need. You see, this number right here, the moles, is N. And then if you looked back, okay, they gave us the pressure in ATMs, and we're going to have to convert this to Kelvin, but we also have those two values. Okay, so the pressure, it's already an ATM, so we don't have to worry about that, 1.950. And the temperature, we do have to change that. That was 25 degrees Celsius. Add 273 and you're going to get 298 Kelvin. And then let's go ahead and put all our numbers into this equation. Remember, R is the ideal gas law constant. So how do we solve for volume? Volume is equal to the moles that we just got up here. 0.09906. And that's moles. Okay, you're going to multiply that by R, which is 0.0821 liter atmospheres over mole times Kelvin. And then we got the temperature at 298 Kelvin. And then we're going to divide all of that by the pressure, which was already in ATMs. And then when we do the math, okay, remember we're looking for volume. You'll see the moles cancel. Okay, so will the ATM, so will the kelvins. The only thing that doesn't cancel is the volume, liters. And when you round to 3 significant digits, you're going to get 2.55 liters as your answer. Okay, so the difference here is we couldn't use 22.4. Had this been at STP, we just get the moles of B multiplied by 22.4 and we are done. Okay? All right, so we got one more that we're going to look at. We had a third practice problem, and it states when heated, ammonium nitrate decomposes. So let's look at this problem. They want to know what mass of ammonium nitrate. That's over here on the left. That's what we're looking for. So we want the mass of this guy, and it's required to produce. Now look at this. All this information has to do with steam. Steam is simply water as a gas. So this is our given. They give us the volume, 10 liters. They give us the temperature. I'll write it over here on the side, 25, which by the way, we just did that. That would be 298 Kelvin. So we got that already in Kelvin. And the pressure, okay, is 752.4 torrs. We are going to have to change that, okay? And I'll do that in just a second. But we have the every piece of information except for moles. Remember, in stoichiometry, the first step is to change to moles. Here's the flow chart. And the only difference is, since it's not at STP, because they gave us a pressure and a temperature, we can't do this. To go from volume to moles, we're going to use PV is equal to nRT, except this time we're looking for moles. And if you carefully rearrange that, PV divided by RT will give you the moles. Okay? So, if we go back here for a second, notice we have the volume, we have the temperature, and what we got to do here is we're going to have to divide here by 760 torrs. okay? And we're going to convert that pressure into ATMs, all right? And let me see, when we do that, we end up getting 0.99 ATMs, okay? So we have all our values. So let's go over here and let's plug in these values here. So we just noticed that the pressure is going to be 0.99 ATMs. The volume was 10 liters. Remember, if it's in milliliters or another unit, you got to change it to liters. R is 0.0821 liter atmospheres over mole times Kelvin. And then your temperature was 298 in Kelvin. And this will give us moles. See, the ATMs will cancel. Okay, this is mole over here. The liters and the Kelvin will cancel. Mole will be the only thing left. And you end up getting that N is equal to 20, I'm sorry, wrong number. N is equal to 0.4046 moles. And this is moles of A. Okay, if you remember, A is water, which is steam. Okay? Now, we don't want moles of A, we want moles of B, which is ammonium nitrate. If you look at the mole ratio, B over A is 1 over 2. Okay, look at the coefficient in front of the ammonium nitrate. It's 1 over 2. So the mole ratio here, we're going to multiply by a half. Okay, and you're going to get 0.2023. And this is going to be moles of ammonium nitrate. Now we're almost done. We got to now find the molar mass of ammonium nitrate and then multiply by it. So let's go ahead and do that. Well, we got nitrogen. There's, if you look at ammonium nitrate, there's 2 nitrogens. Each one is 14.01, so that gives us 28.02. Then the hydrogens, if you notice, there's 4 of them, times 1.01, that's 4.04. And then your oxygen, there's 3 of them, times 16, that's going to give you 48. And then when you add these numbers up, the molar mass is 80.06 grams per mole. So let's do the last step. If we get the moles, 20.2023, and you multiply it by the molar mass, which is 80.06 grams per mole, okay? And we round this to 3 significant digits, you get 16.2 grams of ammonium nitrate, and that is the final answer. So again, remember, when it's not at STP, they'll give you a pressure and a temperature. Make sure it's in ATMs and Kelvin, and then use the ideal gas law, because you're not able to use the 22.4 conversion factor because it's not under STP conditions. So hopefully you got those problems correct. And if you didn't, go back and see if you can figure out what you did wrong. Okay?